So getting back, so once again, so categorical data. For categorical data, we have two types of graphs we can show: bar graphs, pie charts. Okay. Um, there are a couple different kinds of bar graphs. One bar graph you might see is called a segmented bar graph. It's not that hard to read, but sometimes it looks a little weird. Let me show you a picture. Let me show you a picture. This guy right here, it's a bar graph, but it's a segmented bar graph, right? So it just means it's broken up into segments. So in this case, you have age down here and you have percent up here. It's blood pressure. So what percent of people, there's three categories, right? Under 30, from 30 to 49, and over 50. What percent have blood pressure in these areas, right? So the kind of the tan color, that represents low blood pressure. So I don't know, 30, 20, a little under 30% for under 30, a little over 20 for 30 to 49, and a little under 20 for over 50. So it's another way that they do bar graphs, right? They stack them. Instead of like what we did, we could have done stacking. That was a different way we could have done stacking. But for ours, we did side by side. So stacking is just another way of doing side by side. So if I just stack them, that's the only difference. Okay, it's called segmented bar graph or a stacked bar graph. Um, they look different, but they're exactly the same. Okay, and then pie charts. Okay, for quantitative. So now we're going to look at some quantitative data. Quantitative, we use dot plots, stem plots, histograms, box plots. Today we're going to focus on the top two. Histograms we're going to do tomorrow, because histograms is a process. So tomorrow we're going to do histograms. Box plots we'll probably do later in the week. Okay, so here we go. Dot plots. Dot plots are probably the easiest to do, the easiest to read. They're not that bad. We have actually seen a dot plot right there. Instead of dots, sometimes you'll use X's. It's the same thing though. Okay, so the one thing we need is a number line. First thing we need is a number line. Okay, so let's whichever fits the data. You notice how they numbered by 2? We can do that. You can number by 1s, you can number by 5s, whatever you need to. Okay, so let's go to our data. So the data is the combined scores for 2 weeks of NFL games. So for instance, in the first game, the team scored a combined 32 points. So if you add up the two teams together, they scored 32 points. This is for 2 weeks. Okay, I don't know what year it was, but that's how they got the data. Okay. So it looks like the lowest number, let's see, correct me if I'm wrong. I'm seeing 22. I think that's the lowest, right? 16. Yeah, 16 is the lowest. And looks like, yeah, 79 is the highest. So it needs to go from 16 to 79. Now, we don't have to go by ones, 16, 17, 8. That would take too long. We could go by 2s, we could go by 3s, we could go by 5s, we could go by 10s. Really doesn't matter. Okay? There's no right answer. There's no one answer, I should say. Okay? So let's see. Let's create a line. It goes from 16 to 79. So I'm going to go, that's almost 80. So I'll probably go by 10s. That's personal choice. Okay? That's personal choice. That's not anything that's right or wrong. So instead of 16, since I'm going by 10s, I'll probably start with 10 just to make it nice and round. 20, 30, 40, 50, 60, 70, and 80. Okay. All right. And then you're either going to make a dot or you're going to make an X wherever one occurs. So the first one is 32. So at about 32, Yeah, in chronological order 16, but I'll just go in order of the numbers. So 32. It doesn't matter which order you go in. 56, 79. Try to make the dots as big as equal as possible. You don't want one dot to be bigger than the other, so try to make them as equally sized as possible. 59, 23, 35, 37, 24, 48, 49. I'm going down the list and I see I have two 37s. So what do I do if I have two 37s? Put them right on top of each other, stack them. Stack them right on top of the other one. $40, $50, $16, $22, $35. I think I have two 35s. 46. I have two 40. Do I have two 46s? No, I don't. 37. I have three 37s. 44. 59. I think I have two 59s. 38. Do I have another 38? No. Sometimes it's hard to get when you're separating them by tens or fives. Sometimes it's hard to remember what exactly. Just go back to your list. I have 39. I have another 39. Did I have a 39? 25. 44. Another 44. Another 39. 65. 41. 72. 33. Okay. So as you're doing this, what are good and bad things about a dot plot? This is one of the types of graphs. It's not exact, right? It's hard to be exact. Like if you want to know what one of these dots is in between a 40 and 40 and 50, could be 41, could be 42. You think it's 46, 47, not exact, right? That's one of them, not exact. Um, what? So what do you notice about the data? So if you had to say one thing about the data, take cluttered. Yeah, there's clusters, right? Where is the clusters? Is there one? Is there two? Where is the clusters? Right? From about, yeah, a little bit above 30 to about 50 is a huge cluster, right? Huge cluster, right? I would say that's a cluster right there, right? And then we have some gaps. You have some gaps here, You have some gaps here, right? These are gaps. Right? Gap here, gap there, gap, oops, gap there, right? So a lot of the data is clustered around a little bit over 30 to 50. Okay. So we could say if you were going to make a bet as to how many points a team was going to score this weekend, you'd be pretty good to say between 30 and 50 points. That's when combined, because that's where a lot of the data is. Okay. That's where a lot of the data happens to be. Okay. So that's a dot plot. Not hard to do, easy to read. Okay. Stem plot style. Let's do a stem plot. Same data. Same data. Data hasn't changed. Same data, same place it came from. But we're going to do what's called the stem plot. Sometimes it's called the stem and leaf plot. It's not. Sometimes I think you might do. I think in elementary they used to teach stem and leaf plots. It's the same thing. Just instead of stem and leaf, we just say stem plots. Okay. So stem plots are kind of like, they function a lot like dot plots, except they look different. So what do? Okay, so first we have stems. So to create a stem and a leaf, we have a line that goes not down the middle, towards the left. Okay. On the left side is what we call the stems. On the right side is what we call the leaves. So here it is. The stems can be anything, can be tens. It could be a decimal, right? So for example, this data goes from 10 to 80, right? So what I'm going to do here is I'm going to go from 10 to 80. I'm going to number kind of a sideways number line from 10 to 80. Okay. So I'm going to put 1, 2, 3, 4, 5, 6, 7, 8. So you might be thinking, well, where, if it's 10, 20, 30, 40, 50, 60, 70, 80, where is the zeros? Where are the zeros? Those are going to be on the leaf side. The ones is going to be on the leaf side. The tens is on the left side. That's the stems. The leaves are on the ones side. Okay. So for example, the first one, our first number, the lowest one, the guy here, the lowest dot was 16, right? So to represent that, instead of a dot, I'm going to write the number 16 here. So those go together. 1 and 6 make a 16. That represents one of those numbers. Okay. What do you mean the highest? Start with the lowest, and then it's going to go up. So let's say, and then the next one. What's the next one? So we got 16. Let me erase it. Let me scratch out 16. Is there another one in the teens? No, right? That's it. Done with the teens. Now let's go to the 20s. What's the lowest number in the 20s? 22. So we're going to write a 22. We already have the 20. We're just going to write a 2 now. Cross that out. The next one is 23, right? So what we're going to do is we still have the 20. Now we're going to write a 3 right next to it. That represents 23. And then we also have a 24. We have a 25. And that's it for the 20s. So instead of dots, we have the actual numbers. 22, 23, 24, 25. Okay. Now let's go to 30. 30, we don't have any 30s. We don't have any 31s. Do we have 32? 32 though. We have 32. Any other 32s? No. 33s? Yeah, we got a 33. 34s? No. 35s, we have two 35s. So we stack them, we just stack them sideways. 36, we got two 37s, three 37s. No, just two. One, is it three? Yep, you're right. 1, 2, 3. 38, we have one, and then we have two 39s. And that's it for 30s. We got a lot of 30s. Makes sense because in between 30 and 40, we had a lot of dots. Okay. 40s. Let's see. We got a 40. We got a 41. We have 1, 2, 3 44s. A 45, a 46, and a 47. And then we have 48 and 49. Yes, we do. We got a lot of 40s, just like 30s. Made sense. We had a lot of dots in between 40 and 50. 50s. We have a 50, 56, and a 59. Two 59s. All right. Two 59s. We have a 65. And then a 72 and a 79. And 80 we didn't need because we don't have anything over 80. So here's the thing. Because 80 comes at the end, we don't need that 80. What if there was a number like this? What if I added a number? 93. What if there was another number, 93? Then I would need that 80 because I have to list in order. I can't skip numbers. So I would put it down there. 80 would just be blank. Okay? So if it comes at the end, it's like a decimal. If it comes at the end, you don't need the 0. But if it comes in between, you do need the 0. Yeah. Good question. What if that was 124? So what if our stems, what did our stems mean? What did these guys stand for? Tens, right? So how many tens would 124 be? 12. So I would need 8, 9, 10, 11, 12. All of those would be blank except this one would be a 4. Yeah. That's a good question. Okay. So the other thing we need is a key so that someone who's reading this knows what we're talking about. So we need a key. So we say, for example, 16 equals 16. Okay. The reason we do that is because stems won't always be tens. Sometimes they might be hundreds. Sometimes they might be thousands. Sometimes they might be decimals. Sometimes I've seen this. I've seen a key looks like this. 1.6. So now it's not 16, it's 1.6, 2.2, 2.3, 2.4, and so on and so forth. Okay? So having a key helps. Is required because it could be different things. Okay. Okay, so that's a stem plot. The next one is called a back-to-back stem plot. It's the same idea, they're just back-to-back. One's in the front, one's in the back. Okay, so we still need stems. So a teacher gave a final exam to several classes and examined the grades by gender. The following are the results. Make a back-to-back stem plot. So when you're wanting to compare, so we want to compare boys and girls, and it's quantitative data. These are all numbers. I can find the average score, right? So they're quantitative. So we need to do a back-to-back. Okay, we're going to start with the stems, just like we did the last one, right? So what's the smallest number on either one? 40. Is there a 30? 39. Yeah, I see it. I think 30, right? So we got to start with 30, 40, 50, 60. How high did we go? 90? Is there anything over a 9? 98. Yeah, is there anything over 100? I think that's it, right? So that's as high as we go. So just like last one, we draw a stem to separate that, but we go back to back. So you draw it on both sides. Both sides. So let's do the one we're used to before. Let's say the one on the right is going to be boys and the one on the left is going to be girls. Okay, so let's label. This will be boys and this will be girls. Okay, so let's do boys first. 30s. There was a 39, right? 39. So we're going to put a 39 here. 40. 40 for boys. Let's see. Is there any 40s? 40. What's the smallest 40 for boys? 42, I think. Yeah. 42. Then 47 for boys. I'm just doing boys right now. We'll do the girls after. 50s. Let's see. We got a 52. Is there a 49? Let's see. For boys? Yes, there was a 49. Yep. Thank you. Let's see. 50. 53, 52. I think 52 is the smallest. And then 53. And then 59. Yeah, I think that's it. 60. 62. 63. 65. And 66. And 68. There's a 68 over here too. There was a 67? Okay, so I got to move the 68. So to make a 67 and a 68. They got to go in order. So if you make a mistake like that, you got to erase and put it in the order it belongs. You can't go out of order. 70, a little more 70. So we got a 70. We got a 71. We got 1, 2, 72s. 73. 74. 77, two of them. And that's it for the 70s. 80, we got 80, 81, 82. I have two 82s. 84, 85, 86, 288, and that's it. And then the last one is 90, 93, 95, and 98. That's it. Okay, so they're like dot plots because if you turn your head to the side, they stack, right? They stack. If you turn your head kind of a little bit to the side, they stack like the dots do, right? So that's why it's called the stem plot, or it's why it's similar to a stem plot. Okay, same thing with this one here. If you turn your heads to the side, you can see where the 30s and the 40s for the NFL one, those are the highest, right? The 30s and the 40s, that's why we said there was a cluster from 30 to 50, because the ones in the 30s and the 40s there were a lot of them. Here, I would say from like 60 to 90 is a big cluster, right? From 62 to 88 is a huge cluster. Okay. So how do you do the other side? Well, the other side's going to be done the same way, except instead of stacking them to the right in order, we're going to stack them to the left in order. Okay, so let's do girls now. Okay, so let's start with 30. I don't think there was any 30, 39. There was a 39. So we're going to put 39 here. So it's going the opposite way. 39. 39 was for boys. 39 is for girls. Okay. So 40. We got a 40, 42, and a 44. Oops. And a 48. Yep, 48 as well. So you notice how I'm stacking them now. They're going from least to greatest, from left to right. Or sorry, from right to left. So they're stacking in the opposite direction. They're both going away from the middle. So 50, 54, 57, 58. 60, there's a 60. There's a 63. 65, 66, and 67. And a 68. 70. We start with 70. 2 73s. A 75. A 77 and a 79. 80s, we start with 81. 2 81s. 82. 2 82s? Yes, 2 82s. 83, there's 1 83. 84. 85. 2 89s. 3 89s. 1, 2, 3. Yep. And then the last one, there's only 190. It's a 92. We're done. Now there wasn't as many girls scores as boys scores. There was 4 less, right? There were 4 less boys or girls that the teacher had. But when you look at like clumps, clusters, we said the boys cluster was from 62 to 88. Where's a girls cluster from? From where to where? From 60 to 89, yeah, I would say those are the three big. The other ones are like smaller, fairly smaller, from 60 to 89. So similar spot, right? That's where the cluster was. Um, let's see here. So yeah, that's a back-to-back stem plot. And then we need to put key, always put a key for stem plots. So you can pick any number here. It doesn't need to be, I always pick the smallest just because that's where I started, but you can pick any number. You don't even have to pick a number that's on there. I could have said 29 equals 29. Yes. Yes. I always have students miss that. If I have a student miss a stem plot on a test or a quiz, it's because they didn't put a key. Always. If I do have I rarely have students that make mistakes on stem plots, but if they do make a mistake, it's on the key. So yeah, remember, always have a key for a stem plot. You don't need it for any other graph, just a stem plot. Mhm. No, no, you just need one. Yeah. Good question. Do you need one? Because they're going in different directions, right? No, only one. You only need one. It's good enough there. Okay. One second. Florence. No, I don't. No. Oh, no problem. All right. What time is it? What time we got? Okay. So the next one we're gonna start, but we won't finish because this has got a lot of pieces to it. Okay, so this is the one, this is the graph you're gonna see probably most often in all year long. Most often all year long, you're gonna see a histogram. There's good and bad news. The good news is histograms are not, they're easy to read. And after today, we will never do it by hand. After today, when I say today, I mean today after chapter one. After chapter one, we won't do it by hand anymore. The bad news is there's steps to it. It can be it can take a little time to do a histogram, but just know that we can do them on the calculator, and I'll show you how to do them on the calculator. So on test day, I'm not going to ask you to do a histogram by hand. If I ask you to do a histogram, you can use your calculator. And the calculator, to do a histogram on the calculator takes about 30 seconds to a minute. Doing it by hand takes a little longer. Okay. But just know that today I want to show you all the parts of a histogram because it's important to see the components. But just know that we won't do this often. Okay. Okay. So histogram. Histogram is a way to show quantitative data. It's another way. It's a different way, like a dot plot, like a stem plot. Okay. So, first thing we're going to do. First thing you need to do for a histogram. Well, first of all, let's look at the data. The data shows countries, whole mess of countries, and the medals they won at, I believe it's the last Olympics. I'm not sure which Olympics this was, but this was the last Olympics, I believe. So in 2020 was the last Olympics, I believe, or 2021. I can't remember, but this was. So for example, the country of Argentina, it's in South America. They won 6 medals. That's any kind of medals. That's gold medal, silver medal, bronze medal, any type of medal they won for any of the events. 6 people in the country won a medal. Australia, 49 won a medal. Austria, 7, Azerbaijan, 5, Bahamas, 2, and so on and so forth. Okay? So they're all in alphabetical order. Okay, so the first thing you do with a histogram is we're going to make a table. We're going to make a table. So give yourself a little bit of room. So if you need to use the back of that, I think the back page is empty. Okay. Okay, so we're going to make a table with some columns in it. Okay. The first column is going to be intervals. Intervals. That's where we always start with. Okay. So the intervals. Intervals are from here to here. Like however far, like an interval, like for example, our bell schedule is intervals, right? They're called periods. Interval 1 is period 1, interval 2, interval 3, interval 4, so on and so forth, right? That's what's an interval, a smaller section of a whole. So what we have to do is separate into at least 5 sections, at least 5 intervals, all of these countries. We need at least 5 intervals. Let me write that down. At least 5 intervals. Can you have more than 5? Yes. Can you have less than 5? No. Okay. All right. So first thing to do, so when you're trying to decide how to chunk it up, intervals are just chunks, chunks of anything. Well, how far do I need to go from? So what's the lowest number on this list? 1, right? I don't think there's any zeros. There's a whole bunch of them that have 1, starting with Colombia, Dominican Republic. They go on from there. Okay. And then what's the highest number? 103, United States, right? 103. So we go from 1 to 103. Okay, so if I'm going from 1 to 103, how can I chunk that up so that it's even? Even intervals. The intervals have to be even, and I have to have at least 5. I can do, let's try 20s, right? So you can start from 1 to 20, or you can go from 0 to 20. Doesn't matter. Okay? Since there are no zeros, let's just put 1. So 1 to 20. So if I have, don't write this down yet. This is kind of like the process we go through. We're not there yet, but this is kind of the process we go through. Okay, so after 20 has to be 21, right? I can't win 20 and a half medals. You either win a medal or you don't win a medal, right? So 20, 21 to, if we have 20, what's the next one going to be? 40. And then 41 to 60, 61 to 80. What's the next one? 81 to 100. And then the last one is 101 to 120. 1, 2, 3, 4, 5, 6. We have 6 intervals. Are they all exactly the same size? Yeah, how do you know that? If you subtract these two numbers, you get 19, right? If I subtract these two numbers, I get 19. If I subtract these two numbers, I get 19, 19, 19, 19, right? So they're exactly the same size. That works. If you use that correctly, if you use that's your intervals, that would be fine. Is that the only intervals you could do? No, you could have done by tens. I could have done 1 to 10, 11 to 30, or 11 to 20, 21 to 30, so on and so forth. You could do that. You would just have more intervals. It's okay. Okay. Intervals are, that's kind of up to you how wide you want to do it. Okay. So since that one worked, let's do that one. So let's write that one down. So the first one is 1 to 20. So the next one is 21 to 40, 41 to 60, 61 to 80, 81 to 100, and then the last one's 101 to 120. And since we had no numbers above that, we could stop there. That's the first column. The next column is what we call frequency. Frequency. That column is called frequency. What does frequency mean? How often? Yep. How many times does it happen? How often does it happen? It's a number, right? It's a tally mark or a number. right? How many times does it happen? So if I wanted you to count how many times a person comes in that door, you would sit there and you go 1, 2, 3, 4, and then you'd write down the number, right? It's the same thing here. So how many countries have from 1 to 20? So we go and count. Okay, so how many did you guys come up with? Yeah, that's what I came up with too. 62. Okay. So now we're going to do the same thing for 21 to 40. It's a lot less because most of them were in the first one. So what do we got this one? This one goes from 21 to 40. I got 8. 8. Okay. So the next one is 41 to 60. I got 2. 61 to 80. I got 1. 81 to 100. I got 1. And then there's only one above 100. Okay, so we want to add the frequencies up to make sure we didn't leave anything out or added too many. So when I add them all together, I'm going to get 75. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 times 5 columns. Yep, 75. Okay. Okay, the next thing we're going to do, the next column is something called relative frequency. Relative frequency. Still got the word frequency, but now it's relative frequency. Exactly. So my next question is, if someone were to say there are 62 countries who got a medal that scored medals from 1 to 20, my next question is that a lot? Is that a lot of countries? 62. It is a lot because it's a big percentage, right? It's 62 out of 75. That's a lot. That's almost everybody, right? So relative frequency answers that question by turning it into a decimal or a percent. Okay? So we'd say 62 out of 75. Change it to a decimal. To change it to a decimal, we always go 3 places and round. So what was it? 62 divided by 7. Oops. 62 divided by 75. So go 3 places. So 0.826, and then we round from there. So the 6 after it says go up because it's a 6. So 0.827. 0.827. Which is the same as 82.7%. 82.7. Yes, so we're going to do them for each of them. We're going to divide each of them by 75. So 8 divided by 75. When I round, I get 0.107, which is 10.7%. Two out of 75 is 0.027, which is 2.7%. And then the last 3 are all the same. 1 divided by 75, it's 0.013, which is 1.3%. So I don't have to do the math again because it's all the same. Okay. That's the part that takes you the longest, the table. Now, this is one of the only times we're going to do it by hand. Okay, if we have time tomorrow, I'll show you how to do it on the calculator. Okay, tomorrow we're going to start with doing a histogram. I'll give you one to do on your own so you can do it on your own by hand. We'll practice it, and then I'll show you how to do it by hand, or sorry, on the calculator, because the calculators will do it, like I said, all of that they'll do in 3 minutes. Not even 3 minutes, a minute and a half. However much it takes you to plug them in the calculator. Okay, so that's the table. Last part is the graph. That's the part that takes you the shortest. So a graph. So a histogram, if you saw a histogram, you would think, oh, that's a bar graph. But it's not really a bar graph. Exactly, they're touching. Okay? Actually, you know what? I don't want to do this part until tomorrow because we're running low on time and we're not going to finish this. So we'll stop right there. We'll finish it tomorrow. Okay?